8.3 multiplication properties of exponents. This is our first in a series of three different exponential properties that you're going to look at. This one is the most basic, I think. It can't be a video without a yawn. After this, we have the power to a power, and then we have the dividing. So, to multiply powers and to work with scientific notation. All right, multiplying powers with the same base, you keep your base and you add your powers. And that kind of helps up here. Rewrite each expression using each base only once. All right, so if my base is that large number that you see occurring, the larger number is your base, the little tiny number is known as your exponent. So the base is 7, and then we would have 3 plus 2, so 7 to the 5th power. And since you are rewriting each expression using the base, you do want to leave it in this form. 4 to the 4th times 4 to the 1st times 4 to the negative 2. So the base is 4. We have 4 plus 1 minus 2. 4 plus 1 is 5. 5 minus 2 is 3. So this will be 4 to the 3rd power. C, we have 6 to the 8th times 6 to the negative 8. So our base is 6, and we have 8 plus negative 8. Well, 8 and negative 8 are inverse values. They're opposite. So this gives us 6 to the 0, and anything raised to a 0 power is 1. Okay, so you could have it written like this, or you could just have it written like that. I accept both. Alrighty, now we're going to simplify the expressions, the algebraic expressions. This A at the top is probably in the most purest form, and you're not going to see a lot that look like this. So we have P squared times P to the 5th. What is the base? What are you seeing that occurs consistently throughout all of these? That's right. That would be a P. And now you take your powers and you add them up. There is no power here, so we're going to write that 1 in. Okay, so we have P, 2 plus 1 plus 5. 2 plus 1 is 3. 3 plus 5 is 8. So we have P to the 8th power. All right, here we want to multiply the like factors first. 2 times 3 is 6. 6 times 4 is 24. All right, so we've addressed the numeric part of this. P cubed, got him, and then q to the 1st and q to the 4th. So q is going to be 4 plus 1, whereas this 4 plus 1 is obviously 5. So now we have 24 p cubed q to the 5th. Okay. All right, example 3. Simplify, not what I wanted to do. Simplify the two expressions there. Write the answer in scientific notation. That's one of those, no. Okay, the way I did this as a kid was I did 3. It says -3, so that means I have to go this direction to make it smaller. 1, 2, 3. So now we have 0.003. 7 times 10 to the negative 5. So we have 7. And we've got 1, 2, 3, 4, 5. Okay, so we multiply these two numbers together. And we get 0.003. 0.03 times 0.1234 7. That is going to give us 2.1 to the negative 7. So 2.1 times 10 to the negative 7. Now, algebraically, right, we're going to multiply the like terms, the constants together. 3 times 7 is 21, right? 10 to the negative third times 10 to the negative fifth, you are going to be adding your exponents. So we have 10 to the negative 3 times 10 to the negative 5. Keep the base, and then add your powers. Negative 3 minus 5 is negative 8. Where is, let me, sorry, don't know what happened there. All right, so this gives us 10, and then negative 3 plus negative 5 is negative 8. So now we have 21 times 10 to the negative 8. But we have to put this in scientific notation, which states that the decimal comes immediately to the right of the first non-zero digit. All right, so we went from here to here, which means that we added a row. So we're going to go ahead and add a row there. We have 2.1 times 10 to the negative 7. And that matches what we got earlier, so we're good. Does it matter which way you use? No. I definitely would recommend trying your hand at this stuff, though, and not just, trying your hand at this particular part of it. And if you have questions, ask. I'm not going to fuss at you. And was that it? I could have sworn there was another one. Oh, there we go. Oh, we're not doing this one. That's what it is. All right, that is it for the examples. I hope you guys have enjoyed this, relatively speaking, and have a great day.